see that the head is 45 degrees down? All right. Okay, again, he's supposed to be symptomatic. The nystagmus should be present. All right, once he's all done, okay, I want you to hang your feet over the edge of the table on the right side and just sit up. All right, let's come back up and tuck your chin down. All right, hold on right there. How are you feeling?
Dizzy?
That's good. Now you're supposed to be healed.
Venganza.
Oh, much better.
All right. So notice that I'm hanging on to the patient. Don't let him go for another minute or so. Otherwise, you might have that drop attack. All right? Okay, so that's the left Dix Hallpike. This afternoon, excuse me, this afternoon you get a chance to practice. If you want to practice, I'll be happy to be the subject, so critique you if you want. All right, so next step, we're going to do a right sideline maneuver, followed by a Samant maneuver for right PPPB. Okay? So, to do a right, come to the middle of this. Okay. Let me see. We do occasionally bang the patient's head against this. So, I'm going to take a couple of precautionary measures here. All right. Bring your head down and 45 degrees to the left for a right sideline maneuver. Right? Okay? Ready? Here we go. Okay, notice that the nose will be up like that. Okay, he should be symptomatic. Okay, now if you are doing this regularly, you may want not to wear tie, jewelry, of those kinds of things. Occasionally the patients get a hold of that and bang your head against the table as they go through their dizziness. All right. Okay, after the patient's symptoms are gone, this is the body slam motion. Okay, ready? Here we go. Notice that the nose ends up 45 degrees down, which is exactly the thing that they have to do. Okay, can you breathe? All right, so again, the patient's symptoms will go away, and then you bring them back up, tuck your chin down. All right, that's it. All right, any questions? Any complaints, Marco? No, very good. All right, now we're going to do a lateral canal BPPV. Lay down here. We're going to take the pillow away eventually. Just come back to me. Come back backwards. Let your head hang over the edge. Okay. A little bit more. We're going to need more. When you fall, I'll tell you. Okay. All right. Your head up. All right. We're going to assume that he has right lateral canal BPPV. And as I'm doing the testing, you're going to tell me what I'm seeing. Assume that the patient has a right lateral canal BPPV. Okay. You start from here, turn the head right quickly. What am I seeing now? Okay, first I see a little delay. Okay, so now after the delay, what am I going to see?
Torsion.
Torsional? Where did the torsional come from? This is a lateral canal BPPV. So, what am I seeing? Horizontal, what's right beating or left beating?
Left.
Let's assume it's canalithysis. So, what direction am I going to see?
Left beating.
A binary chance, 50-50 chance, right or left?
Right beating.
Okay, right beating, it's going to be very strong because it's a right lateral canal BPPV and I'm turning the head right. Okay. All right. After the symptoms are gone, I'll bring the head back to the center. I wait until he's completely symptom-free and nystagmus-free, and then I'll do this to the left. Now what do I see with the right lateral beating, right beating, anything? I should see left beating the nystagmus. As strong as the other side or not as strong? It won't be as strong as the right side. Okay, so that tells me the patient has lateral canal canalithysis of the right knee. So I would go back to the center, wait, the patient's symptoms are gone, we'll go to the right ear down. Okay, we start from this position, we go 360 degrees and come back to this position. All right? So we do this in 90-degree increments. All right. Okay, you're just going to have to leave your neck completely to me, okay? Just make it as loose as possible. All right. So that's 90 degrees. And again, the patients will be symptomatic here, so just wait until the patient has all the symptoms are gone. Okay. Now I'd like you to just turn on your left shoulder. Again, leave your head for me. Okay? So here we are in the 90 degrees so far. Okay. Now I want you to turn on your stomach and again leave your head for me. It's going to be tilted down. Okay, come closer a little bit to me.
And always you have to wait until the symptoms is gone?
Yeah,
Okay.
exactly. Notice that the head is down 30 degrees at an angle of about 30 degrees. Okay, one more movement to the... Okay, we're back to the starting position. And now just lay on your back. And notice that I'm holding the head here. Okay. That's it. All right. You get a chance to practice this on yourself, or on me, or on Marco, somebody doing after lunch. Any questions?
Can you just show us the Dix Hallpike Maneuver one more time?
To the right or to the left?
Whatever you like.
Okay, let's do to the right since we did the left one. Marco needs to get paid more now for the right. His contract is only for the left side. All right, here we go. That's it. And then you can look at the eye movements.
Okay.
Yeah, we can do it with goggles on. If you do it with goggles on, make sure you put your hand on the goggle. First, you don't want it to fly across the room. The second is that the goggles actually move up during this motion, and you see the eyes, you end up recording the patient's forehead. So you need to make sure that it's on the screen. All right. All right.
Thank you.
You're welcome. All right. Now, last thing, head impulse testing. All right. Come and sit over here. Just legs are hanging over this edge, and face right here. That's good. I'm going to turn this off because I'm getting blind here. All right. Let's do it with a chair. Marco, let's have you sit here with the chair. Okay, you stand in front of the patient, you hold their face in the hand, and you ask them to look at something in front of you. Mostly, the best place would be your nose. Turn their head down, 30 degrees, look at my nose. All right. So basically, you give unexpected, very high velocity, low amplitude thrusts of the head to the right and left. So those are called head impulses. So if you want to stand up so everybody can see, we don't do this in the standing up position, but usually, okay. Just look at my nose. And you can see I'm randomizing. So he doesn't know which direction I'm going to do this head thrust. What I'm looking for, if his vestibular system is intact, his eyes are going to stay right on my nose. Everything moves smoothly, which I'll show you the video in just a second. If he has a vestibular problem on one side, what will happen is that when I'm moving the head quickly to that side, his eyes will fall behind, and he'll have a catch-up saccade. So what I'm looking for is for that catch-up saccade. Now, the bedside test is fine, but you have to train yourself to see the catch-up saccade. So, okay, thank you. Let's see if we can. All right, I'm going to show you. If you're doing this with the ENG goggles, it's really not very effective, because what's going to happen is those ENG goggles or VNG goggles, they just move around too much, they're too heavy. So, but you can get some information. So this is what one of the old those black goggles that some of you might have. So, so I just move the head side to side slowly first, and then do a quick jerk to the center. So that's kind of opposite of what I did with Marco. That's how the University of Sydney people have described it, what I did with Marco. But in practice, when you're doing the goggles, it's better to come from the side to the center rather than the other way around. So I'll show you this one more time. So that's a head thrust to the left. So if she had weakness on the left side, she'll have a catch-up saccade when I did that. Now this is a normal individual. See the thrust, the eye is just right there, no motion whatsoever, no extraneous motion. Let's look at that one more time. So that's when I'm moving the head side to side. And then that's the head thrust right there, and you see that the eyes actually, this is a patient with an abnormal VOR. Did you see that little return? That's what you're looking for. Okay, that's what you're looking for. Now, the problem is, some patients develop a strategy. They know their eyes are going to fall behind. So somewhere during the head motion, they actually send their eyes ahead. So by the time your head motion is done, they're so close to the target that you won't see any saccades. There's actually a name for it. What you just saw, those are called overt saccades, which is visible. And then the other type that's not visible, those will be called covert saccades. They happen during the head motion, so you never know that they're present. So there's a new device. Actually, this is the prototype was built by University of Sydney, and they kind of collaborated with Autometrics. They've come up with these goggles. Very lightweight and very tight. Has one camera, has a gyroscope in here. So you can do this testing actually very accurately. You can see the covert saccades, you can see the overt saccades. So I'm going to demonstrate this on Marco in just a second, but I wanted to show one other thing before we actually demonstrate this. The beauty of the test is that you actually get a kind of like an audiogram, you get a gain for across the different frequencies for each ear independently. And it gives you absolute responses as opposed to the caloric testing where it gives you right and left differences. Currently this device doesn't do it, but there's a, this test can be extended to testing the other canals. It is technically more challenging, but it can be done. So if you want to come back here again with the chair, and we'll do this. You can do the same thing that I was doing in the horizontal plane. Do it in the plane of the vertical canals. So just look at my tie here. this way. Look at the tie. You have to be looking at his eyes though. So those are the planes of the anterior and posterior canals, and the same principle. If the patient's anterior posterior canal is a big difference between right and left ear, you'll see those catch-up saccades. So, all right. So we're ready to do the actual testing. All we need is a wall. All right. Now you can see on the screen, this is area of interest, region of interest. So I make sure that his pupils are in the middle of the region of interest, or his right pupil. This side is kind of like the ENG. You can see the threshold, so that's the pupil. You can also see it in grayscale. You can see the actual. Move around a little bit. Just look around. Okay, good. That's good. So we're not going to make the eyes move that much, so that's fine. All right. Now what you're going to see is that you see the laser dots. Okay, I forgot one thing. Hang on a second. I need a fixation dot for you. Just need to put a sticker there for fixation dot. See that? Okay, just center that fixation dot around the lasers. If you're not seeing this, I don't want to laser you. Just look back on this side. You see there are actually two laser dots coming. So the calibration, as opposed to the old days of VNG, the calibration dots are on the goggles. So you don't have to have a light bar. You don't have anything. You just say, look at the wall and do the calibration. All right, so right there. Center yourself with respect to that. Okay, so just look at the fixation dot. And, okay, the calibration is not going to take more than a few seconds, hopefully. Okay, look at the right dot and the left dot. Okay, so we're ready to do the testing, and I'm going to do the impulses. So just look at the, I need some feedback. I need to see if I'm doing this right or not, and I can't look here. So anyway, we'll just go with assuming I'm doing it right. Like, look at the fixation dot. So what you're seeing on the right-hand side of the screen is the head impulses and the eye movements. So at the end, and I'm randomizing everything so he doesn't really know which direction I'm going, and those white dots are the head velocities that we are measuring. And I like to measure the entire velocity range. So we do about 20 of these. Okay, thank you. Come on back up. So take that up. All right. That was basically equivalent of 4 calorics plus more information. All right. See, those are the right head impulses. These are the left head impulses. I'm sorry. These are the right head impulses. These are the rightward eye movements. So there's a flip. So they match pretty much. This one is the left head impulse, and these are left eye movements. As you can see here, let's blow it up so you can see it. It actually gives you a gain of the VOR over different velocities. So 90 to 200 some, it gives you the gain. And that's the normal limit. So, so you can see that the right and left is actually kind of the same. So that's what you expect from a normal person. It gives you right gain and left gain. Again, this is something we've never had before. Now, if you want to see what happens in a patient, let's take a patient who has overt saccades. Okay, this is a patient who has you see in the right one, the patient's impulses are approximately the same. So that's the right ear. The left side, you see that the impulses are just much smaller than the head velocities in the abnormal range. So this is a patient who has a left-sided lesion. And again, you can see from the gains. Interestingly, we always thought that, okay, one side loss, we always thought, okay, it's that side, but actually it affects the head movement to both directions. So the gain will be reduced on both sides, but it will obviously be abnormal on the side of the weakness. Now, do you see what these are? You see these spikes here? These are those overt saccades that the one video you saw. Those are the overt saccades that this patient is generating because his eyes are not following the head motion. At the end of the head motion, he has to make a jump to catch up with the target. These are the visible saccades. So if you had a video of this, you'll see that the patient's actually eyes are falling behind and making those catch-up saccades. Now let's look at the patient who actually generates covert saccades. Now this patient, the left ear, left head impulses, they're fine. They're approximately equal. The right one, now do you see those impulses, those saccades? These are saccades, and they're occurring right during the head motion. So as an examiner, you won't be able to see these. Yet the gain of the VOR is reduced, and this is a patient with a right-sided abnormality. And what happens here is that these are absolute numbers. As opposed to calorics, not only you're seeing the right and left differences, you can actually see the absolute response. So if the person had a bilateral weakness, both of these will be down here in the abnormal range.
So is this involuntary in that they don't realize they're doing it? Or?
Yeah, it's involuntary. Because their eyes, if the instruction is